point math to add a number to it, right, to make it go flip over A once it does it.
So you're adding the contents of object frame ID to.
Yeah, it's like it's set to 0024. Okay, and then it's gonna force A to be 0 to 2. And then I store it in frame ID. Grab
over top the original.
Yep, grab the direction I'm facing. So 0, 2, 4, 6, 8. So they can offset it in the table, right? Yep, point to the sprites table that takes on the blocks. So this right here.
Check the camera. Okay.
So I get that one first, and I set my. Oh, I think I just figured out. Yeah, I think I figured out exactly why it's going to be.
Okay.
Paul, make sure to use the mic so we can hear you, okay?
I will, sir.
If people are filing in.
Let's go get mine set up first.
Oh, this is going to be a I need 1 second, guys. Sorry. He's still not watching, but that's okay. That's fine. All right. Does it matter which mic I use?
It shouldn't.
Check. Check.
There you
There we go. Okay. I need to pull this thing away from me because I'm super loud in microphones. So my presentation is called Retro Game Video Development in the Modern Era. I'm not going to cover how to code in assembly because I'm probably the worst person to give advice on that. But I am going to kind of go over the tools that I use to help me develop video games. It's made a lot of things easier. And saying that, I'm still working on my current game after 4 years. So, but life gets in the way, right? So what I thought I'd do was I'd kind of try to make it an interactive experience. And we're going to try and build a game today together. And I've gotten really close because yesterday there was a lot of fun happening. And I got super distracted and I didn't get as far as I wanted to. But I got far enough to kind of get the point across. So the game idea that I had originally was I was just going to have this guy that looks like a spy walk around and pick up some items, right? Nothing real crazy. There's no point to the game, just getting the stuff up there and showing you how to do, objects and collision detection. So I was talking to Ken Waters yesterday about, well, what would a spy pick up? And we're like, oh, maybe you get a laptop or you get some sort of other handheld device, and then one of us said disk, and then we thought, we'll change it to David Ladd instead of a spy guy. So we got David Ladd, who's going to be on the screen with various pickups like a floppy disk, a USB to SCSI connection, an FD501, an Arduino, a grease weasel, of course, and he also liked the USB power block. So with that, where I started was on the internet is a wonderful, wonderful Sprite Editor that I use all the time. This was introduced to me by Chet Simpson quite a few years ago. Simon Jonason was my first mentor to do assembly language programming on the CoCo. So I've been we got our first CoCo, I think, when I was like 3 years old. Got a color computer too. I was 3 in 1984. We don't need to hear about And then in 1986, I know we got a CoCo 3, and that's kind of when I kind of hit the road programming in BASIC. And I can just remember always being restricted with my ideas. Either I'd run out of memory, or you have to type in a million lines of HDraw and HPaint, HGit, and HPut. So high school came, got rid of the CoCo pretty much. I can still vividly remember the day that I threw it in the dumpster because my dad said to my brother and I, if you're gonna use it, keep it. If you're not, throw it away. And we looked at each other, we're interested in girls and music. In the trash it went. And I regret that because when I was about 28, I was like, hey, you know what? Ever happened with that old computer I used to use? And I started looking on the internet and I found CoCo3.com and all kinds of different resources. I was really actually blown away to find out that there was a lot of stuff still alive. Fast forward, a little bit, now we have this huge thriving community. Turns out it was always there, but now it's expanding. So I got back into it and I was doing basic programming and ran into the same thing, restricted on what I can do, just time consuming or whatever else. So I think around 2015, 2016, I was begging on Facebook for somebody to teach me assembly language. So I was not smart enough to learn it on my own. And our crazy friend from Denmark, Simon, was like, hey, I'll teach you how to do it. So we built our first game together called Timberman. I had it out on display for the entire weekend. Real simple game. If you've ever played the phone app, you hold it in your hand and you put your finger on there to pick which side of the tree you're going to chop, and you try to avoid these branches. So I adapted that to the Color Computer 3. You use the joystick to go left and then right, hit the button to chop. Probably should have had it up to show you, but that's okay. So all those graphics, I actually wrote a basic Sprite Editor that I was basically H-setting things onto the screen. And then that would write it into data, I would take that when I go to save it, and I would scan the image, right? And I would pull the bytes off, and then I would write them to a disk file by using like the open command. Super slow, but I do a lot of graphics on there. And how you would convert them to be able to be used for a game was you would write another basic program, pull up HScreen2, set your palette, all that good stuff, load them in and watch them slowly go and build on the screen. So get that done, then you go through and you write a code to, H get it all and put it on a buffer. So anyway, I stopped using that and started using GIMP to draw graphics in. And then I would hand code the compiled assembly code to have a compiled sprite. So in case there's anybody who wants to know what the compiled sprite is versus like a sprite, in a lot of cases people will, for a sprite, they'll store an image in memory, basically a buffer of that image. When they want to draw it, they'll point to that, pull over a byte or two, check if it needs to be masked, mask it off, store it to the screen, and kind of just go through it like this. It's fast in assembly, and it's pretty adequate depending on what you're doing. But a compiled sprite, one more note on that, usually takes a lot less memory. Because let's say you have a 16 by 16 sprite. So in this green mode, every byte is 2 pixels horizontally. So that would be an 8 by 16, and that's how much memory it would take. So compiled sprite is you take this image, like this one of David spinning around in a circle. Surprised he's not busy by now. And thank you for wearing the same shirt again today.
I think it's the only one he has.
Now people know they're good. Same colored shirt. Is that better?
Actually, I have 7 of these in my wardrobe, and then I have 3 of the orange ones. So therefore, the inverse. The inverse.
Ah, gotcha. Yeah.
See the theme I was going for? The VDG inverse, orange, green.
Kind of. I was just wondering if you like to spend time in the woods when people are hunting.
No, actually, I like this because where I live, I've got a couple people that don't like to pay attention when they're going through, making their left or right turns, and they don't pay attention to people going through on the sidewalk.
Oh, because you're a pedestrian in the city. That makes sense too. Cool. Well, anyways, thanks for wearing the same colored shirt so that everybody can make the connection. Where was I? Oh yeah, compiled sprites. So what a compiled sprite is I'm gonna write machine language code, or assembly code rather, because machine language is different, to literally draw every byte on the screen, write the instructions to basically like if it was a pencil, right? And it's significantly faster, but it usually takes anywhere from, I'd say, 150% to 200% more memory than a buffered sprite would. But the trade-off in speed is typically worth it, especially with the Coco 3 of today's era, where most people have a minimum of 512K. So you got a lot of pages to work with. So that's kind of a little bit of an explanation of kind of how I came to this point. So a couple of years ago, Simon and Paul Fiscarelli and myself got together and we're like, hey, we should make a game together. We should do this collaborative effort. Because I've always had this firm belief that some of the best games you've ever seen in history are built by a team. But in the Coco community, it seems to be that we do it by ourselves. But seeing D. Bruce Moore's presentation yesterday gave me a different perspective on that. So I might do a lot of the drawing and a lot of the programming myself, physically doing it. But so many people in the community have contributed to my learning experience and offering up suggestions on tools, helping me become a better coder. So I guess I did have a team, I just didn't realize it in that perspective. So anyways, they got a hold of me, hey, let's make this game together. Oh, sweet, cool, let's do it. And Simon had this thing with Ganja Farmer. Have you guys ever seen that?
No.
So it's a PC-based game, 256 colors on a VGA at the time. And you're just this little Jamaican dude on top of a van, and you have a Gatling gun. And there is ganja growing to the left and the right of your van. If you don't know what ganja is, it's marijuana. And then different aircraft from the government will fly by and drop parachuters down. And your job is to shoot them out of the sky and get a high score. And so that was the game we were going to build. And I was like, man, there are so many graphics in this thing. Because on the internet, you can find almost every sprite for every game I've ever made. Spriter's Resource. Look it up. Anyway, so we found all the graphics. And we're ripping over, and I'm like, man, this is going to take me a year to hand code all this compiled sprites. So Paul's like, well, I think I can write a sprite compiler. I want you to take some of these sprites and hand code them for me and optimize them as best you can and give them to me so I can build my sprite compiler. First couple renditions, it's not even coming close to my cycle count numbers. By the fourth or fifth rendition, it was smoking them. And I could literally make the code in a fraction of a second. So that brings me to where I am now. So yesterday, I opened up the Piscal app on the internet. Super intuitive, easy to use program. I'm just going to kind of go over some of the basics, and I'm not going to really physically draw anything for you. That's what I spent most of my time doing, was trying to have assets ready for today. But over here, you can add a new palette, or you can pick one that you already made. And I believe that I saved this one. Maybe I didn't. I think I saved it in GIMP actually. But in any case, you can edit the colors, right? So is anybody familiar with how to manually do an RGB mix on here to make it match a Coco? Good. So you probably are familiar with the way the bits work for RGB. You have 6 bits on the lower half of the byte, and it goes blue, green, red, in order from right to left of intensity. So if you wanted the darkest blue, bit 0 would be set to 1. If you wanted the next one up from that, that would be bit 4 would be set to 1. wanted the brightest blue, well, not exactly the brightest, but the next one from there. Bit 4 would be set to 1, and bit 0 would be set to 1. So how that translates here is you take 255 and you divide it by 3. You get roughly 85. So let's say that I want to make this blue what would be palette slot 9. I don't want any red in there, which is already set up. Don't want any green, and as you can see, the darkest is 85. So the brightest one would be 255, and then if I wanted one down from there, I go to 17. So you kind of figure out your RGB mix. A lot of times, since I can't remember exactly how some colors are made, I'll take my handy dandy calculator out and I will switch it to programmer mode. And let's say I wanted color 49. So I read this binary here and I can see that I got a high set red, high set green, no high set blue, a low set red, low set green, and a low set blue. So that would be 170R, 170G, and 85 blue. I'll go back to
Bingo.
right. 70, 170, and 85. And there I have palette slot 49. So let's just verify that, shall we? And I didn't open up the right one. Sorry, guys. So, our beautiful green screen. Close enough, right? I mean, real close. So I'll set up my palette typically. Last night I didn't because I didn't want to spend a lot of time doing that. And so you have your standard pencil, you have a line, all those various tools. This one's kind of cool because you can paint like that color. Let's say I want to change his shirt to light blue. Do that, and anything that would be that color would change. So actually a better example would be the dark green. Let's say I wanted to do that across all the frames. I press shift and do that, and it's done it over all the frames. So pretty sweet. So undo a lot of that. That looks like garbage. So in reality, what I drew was these 5, 6, and then I just flipped some other ones using this flip. And you can do a rotate, but it only does 90 degrees. There's also other layers. So if you have like the same head, right, and you want to draw a bunch of like running animation, you can create another layer and kind of move things around. So, okay, so that's the Piscal app, and you can save a couple ways. You can save them on your computer, or you can save them in the browser. I kind of do both. The browser is a really quick way to get it. You can also export it. You choose how many columns and rows you want. So we'll actually just do that right now. And you click on download. And I want it to go here. It's going to tell me it's already saved. All right. So then comes in GIMP. Because Paul Fiscarelli was going to write a Piscal file parser for the Sprite compiler, but this is not his primary job or activity in life, so he hasn't gotten that far yet. So what I have to do as a user of his tool is I am going to import those, and basically I would create a sprite sheet like this. So as you can see, we have his idle poses, and each walking pose for each direction are in here. And you have the USB power block. I forgot to mention the Diet Dr. Pepper earlier. That's what that second thing is supposed to be. Does that look like a 2 liter?
Yeah, close enough.
I mean, I made your manual to tell you. But the next thing is a floppy disk with LAD written on it. The next one I believe is the grease weasel. Does that look like a grease weasel or yeah, that's a grease weasel. It's close enough, right? There's a lot of
You
stuff.
look at it
on
cross-eyed,
there.
I think it is.
The next one's a FD501. The next one is a USB to SCSI. You got the Arduino, and the water bottle is important because he needs to mix that with his diet. So what I do is, similarly to what I did in the pistol lab, I set up, I don't know how that got out of there, but I will set up a palette using the RGB blend that I showed you and save it. And the reason that I do that is because I can convert this image into a 16 color bitmap, which is what I need for the Sprite compiler. And if you're doing any kind of like static screen, which I didn't get around to showing you guys this time, but say you wanted to have a cool title screen, you just draw it in this, make sure you're not using any more colors than what you're going to use in your palette, convert it to a bitmap. You got to flip it because of some file format thing. Put that in the hex editor, strip off your header, do a couple things, and boom, it's on the CoCo. That's what we did with my brother's game, the escape room game. If you guys are familiar with that. What actually happened on that one was pretty cool. He did a series of basic commands to draw that screen originally because he's scared of using GIMP. So, or was anyway. He drew that, and we ripped him from the CoCo, put him on here, made him a little cleaner, reverted them back, converted them into a bitmap so that the assembly language program that I wrote to load them would open them up and display them. So you can do a lot of things with GIMP. It's great, awesome graphics editor, very intuitive, lots of support on YouTube for anything you want. So, and it's free.
Yeah.
Everything I'm going to show you today is free. So I set up this palette and I go to File and I go Export As. We want LAD Sprites bitmap, and I hit Export. In this case, I really don't, so I'm not going to go through this all, but yeah, that just means I got another layer. So here's the important part, because this was an area of frustration for me for a long time before I realized it. So there's a compatibilities options button. For whatever reason, when GIMP exports a bitmap, it writes this color space information that no other program does. So I have to shut it off. And then I hit export and it will save it. So after that's done, we bring up Paul Fiscarelli's Sprite Editor. And we open up the file. So this is so rad. I love this program. Even though it's still under development, it's still got a ton of cool stuff in it. So over here is an FCB or FDB, your choice. Assembly language data statements of that entire image. Over here is some descriptions that I can't read. I think it's file size, image size, and I think that's the pixel size there. Bitmap color count is 16. These are important to know because if it's not 16, you're not going to be able to do what you need to do. I don't know what that says, or this, but there's some stuff over here. But more importantly, you got your color palette that you can verify to your GIMP. And the coolest thing about it is if you hover over them, I believe it tells you the palette slot. Yeah, 52, 34. So if you don't know the numbers, which if you're like me, I've memorized them after using them for so much, you can go here and it tells you what you need to do to set up your palette in your actual program. I don't think the CoCo CMP conversion is working quite right yet, but that's supposed to convert it to what would be the equivalent composite palette, but I don't use that. You can do a few other things like having an actual pixel grid, which will grid out each individual pixel, because you can shift this image left and right if you need to make any adjustments in here. You can also see byte boundaries. And here, right here, there's row numbers. So if you look at your byte data, it's got row numbers next to them. Well, if you're gonna copy and paste that anywhere, you might wanna take those out. It used to work. Oh, sorry, this is just for the image. So if I were to get it smaller, it would show me row numbers and column numbers up here. And you can set your transparency color for the sprite that you're gonna make, or a group of them. It's really cool. So I can't really see the top of the screen that well, but in your data here, you can right click and you can change it to FDB statements or not, and you can take the row numbers off. And if you want to paste this into your editor, you would just hit copy and it already selects all of it. Go to your favorite editor. This is not mine anymore. Paste it in.
Boom.
There you go. So that's good for tile sets, things like that. So you don't have to necessarily just convert sprites. You can be converting tile sets as well. I don't know if it's the color of this. It must be the color of this projector, because some of these look like cyan instead of gray. Anyways, you can flip the image in a few different ways, and as you can see, it updates the data every time. Shift it left, right, up, down. So today's demo, I'm going to enable what's called a split. So it's going to break this sheet up into individual sprites. So let's see David Ladd move really quickly. Right, there you go. This is a play button, and all of those missing frames are all the blank spots, obviously, right? And that's one of the things I forgot to mention about the Pistol app, but you guys probably already saw it. It constantly updates the animation so you can kind of edit on the fly, because every once in a while you might just need to move one pixel in a different direction or something. But yeah, this does the same thing. Now I can see it at 8 frames per second if I want to.
Can you make that preview bigger? Because on the webcam we can't see it.
Like this?
Yeah, whatever. Something. Yeah.
There you go. So there's the column and the row numbers, like I said. I want to take those away. Pixel grid and byte boundary. The byte boundary function, I think, is just to kind of maybe, like if you had bytes that could be shifted to the right, you wouldn't have to mask it so much, kind of thing. You know what I mean? I've never done that because I don't care enough about it, but some people do, right? So that option is there. So now I can play it at 8 frames per second. There he is.
Oh, he's a lot more animated on the computer than he is in real life.
So right here it chooses what frame I want to actually like process. And there was a stock blasting option when I started CoCoFEST. It has since been disabled. There's a few bugs that Paul's got to work out on it, so we're not doing the stack blast option right now. But basically, he gives you a couple of different varieties of how you can compile your sprite. You can do a stack blast compile, or you can do an indexed compile. So if you're not familiar with stack blasting, you just move the stack pointer, to the right of where you want to put some bytes, and then you go and you blast it with the data that you want. It's typically faster. Index is going to be store A, comma X, store A, 1, comma X, things like that. It may even use a ABX instead of like an LEAX, depending on how you do this. So my only option right now is to index. The index type would either be using the U register or the X register, kind of as your screen address that you're going to draw the sprite to. I always use U just because I'm so used to it, because when I was hand compiling sprites, I would do a lot of stack blasting. So it was easier to just use U as my screen address pointer, and then do some index stores if I needed to, and then use a stack blast, kind of mix it together to get the fastest sprite possible. So the sprite test you can erase frames, and you can reset the index. So I'm going to show you kind of how this affects something in just a second. So we have our stuff set up. I want to compile frame 1, and I want to use the U register. So, one last important, very important detail. These are your line per row, your height and width settings for the screen. The most important one is the width, because if you don't have the right width on there, it's not going to index to the next line correctly to draw the sprite. So that one is at a minimum needs to be set. And since the 256 pixel mode was really hard to see on this, I bumped everything up to the 128 pixel mode by 2 lines. All right, so I got all my stuff set up to like how my program's gonna run it and compile. Oh, hey, look at that, my sprite's compiled for me. I don't even, it tells me how long it took too, because Paul likes to brag about his work. That took 0.00463 seconds. So here's kind of some of the cool data that you can see from this, right? So my cycle count to process this sprite is 393 cycles. The byte count for the code is 240, but the actual size of the image, like if I was using a sprite buffer, like I talked about in the beginning, would be 128. So nearly double in memory, but I wish he had a cycle count speed for the buffer, because I guarantee you it's probably a quarter of the speed of what that would be. But it really depends on how somebody writes their blitter, you know? So I'm not sure what the byte ratio is. If anybody has any ideas, that would be great. I don't know if that's a byte ratio, like the bytes compared to cycle counts or what. But as you can see, it spits all that out. I made a complaint earlier this year that I had to manually type in all the RTSs. So he built that in for me. And so what I do with this now is I copy it and I paste it. But usually before I do that, I enter in a name that I'm actually going to, the label that I'm actually going to use in my game. So this is my idle pose, and my direction that I'm facing is down. So I just copy and paste all these into the file. But you can also do compile frames. This takes a little longer. And it's going to compile that entire image, which still took half a second. Oh no, that was just for that sprite. I'm sorry. But what's cool is now I can, well, I'm going to put this in there, read that index, and compile those frames again. And I'm going to show you the test. So these affect your test screen. So if you have some like multiple sprite frames compiled over here, you're going to want to say erase frames, because when you do the test, it'll actually animate everything at the frame rate that you set up above. And resetting the index just means it's going to go back to the beginning. So I hit this test button and it's going to launch VCC, and everything gets animated for me on the CoCo at 8 frames per second. So that's pretty cool. If I would have taken all those dead spaces out of there, it would have been a lot better. But you can also do a single frame if you wanted to, just to kind of see, okay, cool, that's working, awesome. So now I know that it's going to work when I put it in my assembly game. So that's the first part of that setup that I do. I generally start with graphics because that's what I enjoy. I don't really enjoy programming, but I do it because that's the only way I can make some of the games I want to play. I do enjoy it, actually. I shouldn't say that. It's a frustrating thing, because there's like 12 revisions of something that doesn't work until something finally does. So there's a lot of breaking and there's a lot of debugging. I don't think anybody really likes that, you know, that's a programmer, but what's really cool about a programmer is taking something that is nothing and making something out of it. And I actually kind of enjoy making games more than I do playing them because of the challenge that presents. I feel is greater than video games. You know, it's like trying to solve a puzzle in itself. So, all right. So, any questions on this or anything that I've gone over so far? No, cool.
What was the licensing fee to get David Ladd's likeness in your program?
Diet Dr. Pepper. Actually, I paid him nothing. He's a great sport though, man. I mean, hey, can I make fun of you publicly? Yes. Okay. Cool. You can, yeah, I do it that way because it's easier. Because you move by a single byte, yes. But sometimes you can do single pixels, but you have to have multiple screen buffers to do that.
Well, otherwise, the point is you just have an option to compile for each Sprite version in its position and one pixel.
Yeah, so what you would do, so let's say I wanted to do, I'm just going to reopen this, and I can demonstrate that for you very easily. So let's say I want to do this whole thing, one pixel right or left. So I'm going to shift it, and then I'm going to enable my split, and now everything's one pixel to the right. So that's a great question, actually, because some people are going to want to do that. So, any other questions? Okay, cool. So, another program that probably everybody's familiar with that I use as a tool is Excel. And Excel is basically my electronic equivalent of this thing that I used to spend lots of time writing in and making notes. So basically, I will use it for my memory maps. I will use it for my what I'm going to name my sprites. Right here, I have an object variable table. I'm going to zoom this in a little bit better. So I'm going to talk a little bit about how I set up data structures for my my objects. But basically, I have this kind of pre-calculate how far of an offset it is from the beginning of the, oops, that did not work. This tells me how far off this byte or this variable is from the address of the beginning of the data. I think I explained that correctly. So for an object, I have a table somewhere in memory, and that table contains all of these different variables in it. And this location number is how far from the beginning of that address that specific set of data is. And I put in the length and then the name that I'm going to use. And these are kind of standard object variables for me. Ones I added to this one were object box x01 and y01. I was going to do a bounding box collision detection style with this, and I haven't got that far yet. I have an idea of how it's going to work, but I'm not positive. So let me open up the one that I have for CoCoBound, and I'll show you. That one's a little bit more elaborate. I can't see anything. Okay. Browse, desktop. It is this one right here. So we'll zoom this baby in a little bit more. And I actually saw another programmer that I'm friends with adapt this. So that made me really happy that somebody else was using it. So one of the things I'll do is I'll do my memory map in here. Kind of just helps create a visual for me of how I'm going to organize all the different pages I'm going to use and where I'm going to set the MMU to bring them into the 64K of memory. Because if you don't know, the Color Computer 3 has more than 64K, but the CPU can only access 64 of it at a time. So they have a memory management unit so that you can bring in 8 chunk bytes when you need to and assign them to certain physical address spaces. So I go through and I, kind of my task, and I name off, the actual address number for that MMU register. And over here I have the physical address, so I know what kind of space it takes. And some of this stuff you memorize after a while, but still kind of need to set it up this way. And so the possible pages that I'd be using that memory space for. So this one, for example, has 4 different ones. Page 30 hexadecimal and 31 hexadecimal are the actual screens that the player sees. So I use double buffering in almost every game I have. So 30 is one that'll show, 31's being worked on, and then they flip back and forth. And then 37 actually contains the background image. So one of the techniques that I learned from Chet Simpson, so for restoring the screen behind sprites, some people will say, hey, I'm going to put my sprite here. I'm going to grab all that data and put it into a buffer so I can copy it back later. So Chet's technique takes more memory, but it saves you time. You have a clean copy of your background in memory, and you just go and you copy the bytes from that background right to your screen so that you don't have to create a buffer. The buffer's already there. And since it's been 4 years in development, I don't remember what I was going to use 3B for, so I'm going to look over here. Oh, the title screen is 3B. So I use that memory space to fill those blocks in when I need to. And this chart helps me keep track, as you just saw, because I couldn't remember what 3B was. So I have this chart over here for what each page has on it. So I use Excel for that. Over here, I built an asset chart, which is like what I just showed you with David Ladd. So I have my label. I have the address that it's going to be in, because I have to make equates for all of those, which I'll show you in a second. I'm sorry. This is telling me what the asset is. This is the label that I'm going to use in my assembly program. And over here, I don't know why I didn't just, I think in the first revision I didn't compile all these, but I was letting myself know if they were compiled or not, because they have to be handled differently if they are. And then I have a list of direct page variables, because I will forget them or overwrite them if I don't keep track. So I used to write all this in my notebook. And then the object variables that I'm going to use, same kind of chart I showed you there. And then this one, this was my, CoCoBond works on a grid-based system. And so I was trying to figure out, the yellow ones are the player and the blue one is the beholder. So I was trying to figure out like what it was going to, it takes the screen address of the player and subtracts the screen address of the beholder, and then figures out if he's above or below or on the same plane or left or right or on the same plane. So I was trying to figure out what the actual physical address numbers would be by putting different boxes on there. So that is what I use Excel for. I mean, you could probably do a lot of different things with it. This program is not free, but there is Open Office. You should probably know that. So now onward to what I actually use to code. I started here. Terrible. But you don't realize it, you know. Because if I want to find something in here, you know, I can use Control F and find it or whatever, but nothing really sticks out visually. Paul Fiscarelli did a video series called Long Branch Never. And if you are going to get into this, I strongly suggest you watch it. It's really short, but it helps you set up so many tools to make your actual assembly development real quick. So I'm just going to show you like everything that we set up. This is my assembly language program. I use LW Assembler as my assembler. I use Notepad++ as my editor. Now this is the coolest thing that has ever happened to me as a developer. I hit F6, I hit enter, and instantaneously my program is executing. So I don't know about you, but when I would program in BASIC, does it work? Run. Here it goes, right? So the reason that assembled so quickly, one, it's small. Two, oh, don't do that. I didn't want you to do that again. Oh, it closed it. Sorry. There is this option in LWASM, see if I can get this closer, called Forward Ref Max, which Simon and Paul just introduced to me a few weeks ago. And somehow this forces the assembler to not do as many checks as it normally would. So it just goes boom and instantaneously, assembles your program. So earlier, I compiled my sprites and I copied and pasted them into my notepad file. And I didn't use any includes. Now normally I would, so if you want to see what I'm talking about, I will open up my latest rev of CoCoFEST. Well, this one right here. So instead of having this giant listing like I do today, I have lots of small modules, which was something that I did not do in Timberman, and did not do for a long time, and didn't really understand it. So Timberman's like this giant listing. So every time I'd have to go through and edit anything, I'd have to scroll through the whole thing, and I didn't know how to use equates back then either. So anything that was like the same value repeated, I didn't have any equates for, so I'd have to go through and physically find them all and change them. But so now I do a lot of includes, and there's still some, I could be better at this, that's for sure. But in this demo, I was trying to just get it done so fast, I didn't do any of the includes. So I pasted that code into the end of it instead of having an include file, which may have actually taken longer now that I think about it. So then I started, from there, I just started building my assembly file that I needed to build. So I started, this equate list has gotten larger as I started. Normally I would have that as an include file right in the beginning, and I would just have it on a separate tab so I could reference it really quickly. So yeah, and then I just started building my chunks. Now, how this all works for assembling it and booting it is this assemb.bat file that Paul actually has available. He tells you in his Long Branch Never series where to get everything you need to do it. And this file is included in there. So you I think there's a spot where you don't need to edit past, but the biggest thing is it sets your LW tools path for your assembler. This is how I get to VCC. It also can launch MAME and the MAME debugger at the same time. As what this does is it takes your binary output and it writes it to a disk and it opens up in all the emulators on your computer. And then right here is where you actually put your path in for it to find your assembly file to assemble it and then put it into a binary and execute it. So it's pretty easy to edit. That's usually all I do ever edit is this, path to where it is. So as you can see, I've had a few different, projects going on. So every time I create a new project, I just rim statement out the one I don't want to use and put in a new one, or delete the comment symbol in front of it. So started building this yesterday at 5. Got super distracted by all of the music going on and the fun shenanigans. And you know what I said to myself? I'm here to have a good time. I think my presentation will be fine. So I slacked off for a while, and this is as far as I've gotten. So I was going to randomly put the pickups about on the screen, but instead I didn't feel like pulling in my random number generator, which is actually in my library. So I just set points to it. And as you can see, he's on the screen. So the red border is measuring how much time it takes to, I'm clearing the entire screen and I'm rendering every single object. And I'm also processing David's every move. So for whatever reason, I can't get the walking to animate right now other than the first frame. So I still have to figure out that problem. But here's where I am in a day with everything that I've used as a tool. Because if I would have tried to hand compile all of those sprites yesterday, I wouldn't have anything to show you. So, yeah, is there any questions right now? I was going to kind of go over some of the code, but I mean, that's kind of boring depending on who you are, and I don't want to be subject to criticism either.
Do you have a place where all of the apps that you have are linked to, so that we can say, go to a site and say, oh, go to this GitHub or go to this?
Yeah, so in the Long Branch Never series, Paul has all of those resources.
Okay.
The only thing that I can think of that I use that he doesn't have is the binary editor that I use is called HDX. It's free. Show you that real quick. And then Hearing of Dragon fame. What's that emulator he made? Xroar. Correct. He has a compressor that I use that Simon showed me years ago. But there's other compressors out there in the community I've heard about.
Yeah, because they did the Long Branch Never, and all of that, editing that map file was amazingly awesome for setting up include files and stuff like that, and all of your stuff like the Sprite Editor and the editor.
Oh, yeah.
Everything like that. It's like, none of that's in there because that's all you guys.
Cool. So I need to make something where everybody can get that. I agree with that.
Yeah.
But the Piscal app is just piscal.com. You're there. That's where you can go to edit that. And then GIMP as well. If you Google either one of those, you'll find them. But I can create a link. I'm not sure where should we host it, Steve.
I can create a page if you want to give me a list of links. I'll put them on a page somewhere.
Yeah, cool. Because I did a presentation. Was it last November, where I went over all the tools I use, and in that presentation I had all of where you get them. And I was going to do that again this time, but I ran out of time, Terry. So yeah. I apologize.
If you give me the links, I'll make a page.
Yeah. Cool. So I'm gonna work on that page after we leave the festival.
It'll be available to everybody except Terry Steen, just so you
correct.
know.
Yes. We're gonna set up a proxy detector. Does anybody have any other questions?
Can you move him around? Can you move up and down?
I can't do that yet because I didn't get that far. I was working on that when you said, "Hey, you're going on in 20 minutes."
No pressure.
And then I had to go to the bathroom for some reason. So anyway, I was gonna do that. And I'm having trouble. Like the last thing I tried to do was when he goes in that direction, I actually want him to animate right now but not move. So that was my first step. And I kind of build it in phases. And I was originally going to kind of do each phase. But then I forgot to just kind of save my stages of assembly to kind of show the different stages of what I went through. But yeah, so the first thing you got to do, obviously, is, set up all your different stuff like high speed, what video mode you're going to use. I set the palettes to black so nobody can see it. I'm sorry, this is actually setting up the CoCo3 to be in CoCo3 graphics mode with, I believe, the IRQ and the FRIQ would both work, but I still have to set the register to trigger them. But I disabled them in the beginning, but when I go to use them, I would enable them. This is actually setting up the screen mode that I use. And then here is how I'm setting up all my different objects. So it's kind of one of the things I wanted to go through because this was a technique that Chet Simpson showed me that has really changed the way that I program video games. Because I used to use, back in the early 2000s, a guy named Mark Overmars created Game Maker for the PC. And he's from Denmark. And it used to be $18 for a full registered version of Game Maker. It is now like $700 because Yo-Yo Games bought them out. But anyways, it was an object-oriented graphical user interface to make games with, and you would create all these objects. And at the time, I didn't realize, but there's all these variables these like built-in variables that were associated with it. And it always worked really well. But when I started programming in assembly, I didn't really make the connection of how to handle objects. So Chet was like, I was working on a game, and he's like, why are you writing this huge loop of handling every single object that you have, and there was no way to uniquely identify any object from any other object? And I was like, well, I don't know, because I don't know what I'm doing, right? So please help me. So he showed me this technique where he creates, in memory, like I said, you create a data structure of variables. So that data structure contains the screen position, the frame ID, the direction, the frame rate, the state, which is used for like if you have, I'll show you in a second with CoCoFEST, the beholder will stand there and look at you, and then he'll blink every once in a while. So it's changing the state so that you know what sprites to be using and things like that. Which sprite frame you're on and which sprite you're using. The current function that executes, so some objects might have different things that they do, so you write a different function for each thing that it does. And that just stores the address of where that function is, so you can jump there. And like I said, I added these this time for the bounding box locations. What I was going to do was take the bounding box location of the object, compare it to mine, and see if we have a collision. Should be pretty simple. Simple in words, maybe not so much in execution. And then lastly is the next object. So it creates a linked list of objects. So you start by executing the first one, and when it updates everything it's supposed to update, it says, hey, what's the next object? And if there's one there, it will jump there. If it doesn't, it goes back to your game loop for rendering. So how this works in assembly is you use the Y register, which everybody hates to use, but because it takes that extra cycle. But it's a great thing for pointing for objects, because then you can use U, you can use X, and you can use D for all of the update functions that you want to do. So this is me setting up that object. Normally, like in CoCoFEST, I have a level parser, so it goes through the entire level with the level editor that I've created, and it takes each grid space and it says, hey, what do I have? Oh, I have a wall. Cool, I'm going to do these things. I have this character. Now I'm going to set this all up. So that stuff sets that all up for me. This I kind of hard-coded for specific locations on the screen. But the first thing I do is I point to my object. So in this case, it's Mr. Lad. And then I loaded a hard address, and I stored that in the object screen position variable into Y. So Y is pointing at that data structure, right? And at 0, so at that address, I'm putting my screen address. I pointed to the idle down sprite that you saw me make before, and I stored that as the sprite frame. So in the rendering routine, it says, grab this sprite frame, go draw it. So I'm setting that up as the thing to draw. And sprite idle, which is a table of the frames that are in there, and I set that as the object sprite. So let's kind of look at that a little bit down here. I have a table set up. I gotta get these includes in here. So sprite idle. So this is a sprite that contains frames in the table. So that's the idle down right, idle upright, idle up, all those, etc. It points to the address of the compiled sprite in memory. So I build that table, and that's that sprite, and I can call each individual frame out from there. And so I also have to create, I have to have labels down here, that say what the sprites are so that I can populate these tables. And then the same thing here, so sprite walk down. So if I move my joystick down, I still have it up. It says, my sprite now is the walking down sprite, and I want you to go to X frame within that sprite and draw it on the screen. But as you can see, that doesn't work right now. But that's what I'm referencing up here when I'm setting that player up. Excuse me, right there. Cool. So then I'm clearing D so that I can have some zeros, and I set the direction at 0, so the default 1. I have a frame ID, and so how the frame ID works, and this is something I learned from Tech Simpson as well. I use what's called 8-8 fixed point math, and what that means is if I'm using register D, which is a cumulative of A and B, A is my integer and B is my decimal / fraction. And what you do is I have a frame rate value. So let's say that's 0040. And I'll add that to D every time. And so it controls the frame rate. So once it hits over 255, that'll roll my integer to the next frame that I need. And then you set a maximum so it doesn't go 0 through 3 or whatever you want it to be. So that's how the frame ID works. And then you just take register A and you go into your sprite index for your frame and you grab that and you draw that. Theoretically, it doesn't work right now. And then I'm setting up the object box for the collision detection. I load the function that I want processed and I store it there. And then I'm setting up object 0 to be the next object that I want. And I'm storing the frame rate. So how this translates later, so I set up the 2-liter and a floppy disk and all that other stuff, is in my game loop. Real small. I check my vsync. I set my border color so I can see how long everything's taking. I flip my work page and my show page. I clear the screen. I go get some joystick input. And then I point to the David Ladd object, and I jump to that function, which begins the chain of the linked list. And his function, right now, I grab my joystick return values, and this is really crappy. I would not normally do this, but I'm like comparing basically everything. And so I'm changing my direction variable when I get joystick input based on what I got. And that feeds into the next set of sub-functions, which would be David set idle. So when I'm standing still, I'm gonna grab the idle sprite, set that as my object sprite. Probably don't need to do that, but I do in this case. Get my direction, add it to the table offset, and then I set that as the sprite frame that I want to draw, and then I return. So I'm updating the object data that's used for the rest. The other one was the one that doesn't work is his walking sequence. So what's supposed to happen here is I'm supposed to grab the frame ID variable, and I'm going to add my frame rate to it. And if register A goes above 3, I want it to go back to 0, and that's what the AND 4 does. Depending on the number, you can do that. Sometimes you have to do a compare to see if you're at the max and reset it. But in this case, I was lucky enough to be able to AND it. And then I would store my new frame ID. So then I'm going to grab my direction, and I'm going to point to the walk sprites, and I'm going to go in there and say, hey, I'm facing down right, so give me that set of sprite frames. And that's what I do with the load X. And then I logically slip A because I have 0 through 3, but I want 0, 2, 4, or 6 to go into my table. And I grab the frame that I need, and I set that as the frame to draw right here, and then I return. And the next thing that the game loop does is it goes to render objects right here. So I wanted David Ladd to always be on top. So I realized what I just said. Have I gone over my hour by the way?
It doesn't matter. You're the last show, dude. So
Cool. So I started at my second object, and I say, all right, give me the sprite frame that I want to draw. If there's nothing in there, which means I picked it up, I'm not going to draw it, so I'm just going to go down to the end here. But if I do, I'm going to load you with the screen position of that object, and I'm just going to jump right to the sprite frame, and I'm going to draw it. and then I'm gonna load the next object, and if it's not blank, I'll go grab another object. So the last object that you create should have zeros in the next object data set, so that it says, oh, that's my terminator value. So then after that, I grab David, I grab his screen position, I grab his sprite ring, and I draw it. And then I should be returning.
You grabbing David while he's on top?
So actually that should be a jump to that render, and that might be what my problem is, because it should render and then just return back to the game loop when it's done. Cool, figured that out while I was talking to you guys. So, I'm going to. I didn't need to erase the J, but you know, that stuff happens. And we'll kill that other one so that I can run my new one. I bet you I broke it more, David. How much you want to bet? You want to bet a 2-liter Diet Dr. Pepper?
You like that?
I think the first one should have been.
Sweet. Nice. Love it. Great. I think the first one should be a JSR, like I heard in the crowd. Thank you very much. Yeah, because I'm not going to return. You're correct. Good call. Thank you.
Do it live. Do it live.
Do it live. Do it. We're doing it live. Okay. No, I'm still not getting animation, but he's doing the same thing he did before.
At least he's got the full range of motion now.
He did before. I
You
just
did?
didn't do
Okay.
it. Yeah.
Now you just can't offset.
Yeah, I'm not able to. It's not referencing the right sprite in some cases.
Ninja.
Yeah, right? David, Lad Ninja, Super Ninja. Anyway, so with that said, I've used all of those tools and those techniques that I went over and that to create what I'm hoping to be done as soon as possible. Because I'm getting tired of working on it. I got some other ideas. Let me close this down. I'm sorry, guys. I'm not used to working on one screen here.
What editor is that?
This is Notepad++.
Okay.
What is going on? Why am I getting errors? Oh, I know why, because I didn't change my SM file. That's why. This is the one I want. And I was hoping to have this done by CoCoFEST, but summer came and life got in the way, and I snowmobiled a lot this winter. What is this all about? Oh, I'm trying to assemble my batch file. I'm such an idiot. Yay, finally. Holy Christ. All right. I used all of these tools and more, and all of those techniques to create what will be CoCoBond someday. Hopefully sooner than later, like I said. There's going to be a level editor in this game so that you can create and play custom levels with you and your friends. Take the file, put it on a virtual disk, send it to Steve Strobich, say, hey, check out my levels, what do you think? You got a bunch of icons on the left that do various things. This is joystick controlled. I think I enabled the break key here. Yes, I did. Cool. And the game itself, you're going to have 5 save slots. A star means that you have something saved there. I'm going to overwrite that. So there it is in all its glory. I have some bugs to work out. And I am currently I'm going to start revision 8 of this game to hopefully clear out some of the bugs, because it seems like every time I add a new module, I break something else. And I had some really strange things happening that were really hard to debug. But the premise of this game is I'm going to try and get that green gem down in the bottom right corner. There are some black spaces, like for example, you see the key on the left? There's supposed to be a lock right there, but I have not programmed the functions for the locks yet. So certain locks are unlocked by doing certain things. So one, there's an orange colored lock In this case, it's right here. That lock is unlocked or disappears like it is now when you pick up that key on the left side. There's another lock that is gray with a black keyhole. And what that does is when you take these gems and you fill all those slots, you would unlock that keyhole or that lock. And the last lock is one of my favorites. So over here on the left, there's 3, and up there, there's 1 laser emitter. And you can use mirrors to reflect those. And those little gray blocks, the blue, are receptacles for those lasers. Fill all the receptacles, unlock the laser lock. And then usually you can defeat the level. And not in the very beginning, but later on, there's our friend the Beholder down there. He tends to be pretty lethal. And he's gonna follow you around. So, as you can see, he's staring at you, and he can't wait to get you, but he can't go past any lasers, because lasers will kill him. And I've gotten a laser to kill him twice in this level, and I can't remember how I did it. But, anyways, when he will kill you if you run into him, kind of thing like that. So that's as far as I've gotten. I also have some, these are portals over here. Oops, almost died. And that'll bring you up here. So I think the idea in that specific one was to push this gem through the portal, put it in that slot. Now I gotta get out. And these right here are death spaces once you can pass through them. See, there's one of my errors. I don't have lasers anymore. So I was gonna show you the mirrors, but I have an error. A timer's gonna go. I had some trophies set up for different parts for different levels, but I don't think I'm gonna do that anymore. It's just a lot of work. So best time is kind of the thing you would do here. And you can exit out. I wonder if I restart the game, my laser error is gone. It's not, of course not. So, any questions, guys? I think I'm done here. Talking. No feature creep. So, I hope that I went over some stuff that might help anybody who's interested in starting or is currently doing this and would like to make things easier on themselves. So, yeah.
Can I just think the David Ladd thing, have some elevators so I can get stuck in one?
Yeah. Maybe next CoCoFEST I'll have this working. So have a little elevator entrance for him again. Yeah, cool. Well, thanks for listening, everybody.
You rock, Polly.
Yeah, have safe travels for everybody.
Good job.
Thanks. How long did that take?
You've been going for about maybe a little over an hour, because we first started the stream 2 minutes before, 5 minutes before you started.
Cool.
So like an hour and 5 minutes or whatever.
Sweet.
And only tell they 3.
And I added stuff, so.
Yeah.
And we'll talk to them real quick, and then we'll.
Yeah, no problem. Thank you.